Good morning, children. Once again, today we will discuss the physical properties of metals. Previous class we discussed some physical properties. Today we will continue the remaining physical properties. That is, one, sonority. Second one is ductility. Third one is malleability. Fourth one, conductivity. These are the four physical properties today we will try to discuss. The first one is sonority. What is mean by sonority? In your textbook, this sonority concept he explained by taking a simple activity. So we will also learn like an activity only. Aim. What is our aim? Identifying the materials which are sonorous. Identifying the materials which are sonorous. That means for this some materials we have to take. So materials required. So in this I am taking some materials. So what are the materials? Iron I am taking. And zinc I am taking. Copper I am taking. And sulfur, carbon, aluminium, etc. Okay, how can we take sulfur? It is in the form of a powder. How can we take carbon? It is in the form of a powder. How can we take these two means? We will take in the form of a packets, a tiny packets of sulfur powder and a tiny packets of carbon powder. So these are the materials I want to take to conduct the experiment. Then procedure. Take one by one each and every material and drop on a hard surface. What I am saying? Take each and every material one by one, drop on a hard surface. When you drop on a hard surface, identify which elements or which materials are giving ringing sound and which materials are not giving ringing sound. Here, these all are the metals. Here, these all are the metals. It gives a ringing sound. And these are the non-metals. It does not give any ringing sound. So what I am saying? These elements or these materials are giving ringing sound and these materials are not giving ringing sound. Okay, so what I am saying, the materials which gives the ringing sound when it falls on a hard surface, that property is called as a sonority. Here we know already iron, copper, aluminum, these all are what? Metals. That means what is the conclusion I am giving here? The elements are the materials which gives the ringing sound. The materials which gives the ringing sound are called as metals. The materials which gives the ringing sound are called as metals. And the materials which does not give the ringing sound are called as non-metals. Sir, does all the metals will give the ringing sound, sir? No. Why? We know some of the metals. What is that metals? Mercury. It is liquid in nature. And sodium, although it is a solid, very soft in nature, and potassium, it is also solid only but soft in nature. These three, if you drop on a hard surface, these three will not give a ringing sound. These three will not give a ringing sound. That's why some exceptions are there. That's why what is the statement I am saying? Most of the metals are sonorous in nature. That means they will give ringing sound when it fall on a hard surface. Non-metals are not sonorous. That means they will not give ringing sound when they fall on a hard surface. Is it clear, children? So previous year, you are getting a very important question from this concept. What is that important question? They are asking the question like this: why the wooden is not used as a bell in your schools? Why the wood is not used as a bell in your schools? We know that wood is a non-metal. It does not give any ringing sound. That's why we can't able to use the wood as a bell in our school. Okay, now, but this year maybe chances, every time I ask the same question, this year maybe the chance it will ask like a activity. That's why I explained aim, material required, procedure. What is the procedure? Take these elements one by one. Second point, what is? Drop each and every element on a hard surface. Third one, observe the sound produced by each and every material. Next, observation. Prepare one table and I gave the total notes in a PPTs. Note down that everything. Next, we will go to the next property. What is the next property? Ductility. What is the next property? Ductility. What is meant by ductility? What is meant by ductility? Ductility is simply nothing but the process of making the substance into thin wires. What is the ductility means? The property of making the substances into thin wires. This property we are calling as a ductility. Nowadays we are observing so many metals are available in the form of wires. Very first one is gold. Gold is a metal. If we take 1 gram of a gold, approximately 2 kilometers thin wire we can make from 1 gram of a gold. That much of very thin wire like structures we can make by using the gold metal. And one more metal, if we take tungsten. Okay, now, in your bulb, in your 100-watt bulb and 60-watt bulbs, if you observe, a filament will be available. The filament is made up of this tungsten metal. The filament is made up of tungsten metal. In that filament, when it glows, then only you can see the filament. Otherwise, it is very thin in nature. That's why invisible. That much of very thin wire also we can make it from this tungsten metal. Like that, by using the metals we can convert into wires. This phenomena, this property of a metal is called as a ductility. What is meant by ductility? The property of converting the materials into thin wires. So how the non-metals are? Non-metals are non-ductile. Non-ductile. That means non-metals we can't able to make it into thin wires. Non-metals we can't able to convert into thin wires. Sir, any exceptions are there, sir? Exception is carbon fibers. Carbon fibers. Whatever may be the plastic you are observing, in that plastic carbon is there. That is a very thin fiber like structures are available. Carbon is a, although non-metal, it can be made it into very, very thin wires. That's why carbon is a non-metal, it is exception. Remaining all non-metals are non-ductile, metals are ductile in nature. Next we will go to the next property. Next property is malleable. Malleability. What is mean by malleability? It is simply nothing but ductile means the property of converting into thin wires, I said. Malleability means the property of converting into thin sheets. Nowadays we have aluminium foils, sodium foils, so many foils are available. That means we are making the metals into very, very thin sheet-like structures. Very, very thin sheet-like structures. This phenomena or this property is called as a malleability. Because of this property only, our civilizations are having different names. In the olden days, our civilization, next we are calling as a Bronze Age civilization. That means at that time, they prepared all their ornaments and all their materials to hunt the animals and everything by using a bronze. That era we will call it as a Bronze Age civilization. Next they start using the iron. That's why that civilization we will call it as a Iron Age civilization. How they prepared all their weapons to hunt the animals by using these metals. They know the metals are having the property of malleability. They beat it into flattened sheets and they made different type of weapons to hunt the animals. So the malleability is one of the best physical property of a metals. Is it clear, children? And any exceptions are there? Yes. What are the exceptions? What are the exceptions? So already we know mercury is a liquid in nature. Sorry. Mercury is a liquid in nature. That's why we can't able to beat it into thin sheets. And not only that, zinc also. Zinc also. Sir, zinc is a strong metal, na sir. Why we can't able to beat it into thin sheets, sir? Because zinc will break easily. So if we try to make it into sheets, it will break. That's why we can't able to make the zinc also as a thin sheets. These are the exceptions. These are the exceptions. Next we will go to the concept of the conductivity. Next we will go to the concept of conductivity. In this conductivity, we have to learn two conductivities. One is electric conductivity. Another one is heat conductivity. Electric conductivity. Another one is heat. Conductivity of electricity and conductivity of heat. First we will discuss the electric conductivity of metals. Electric conductivity of metals. Every year compulsory you are getting one question from this concept. Okay, we will discuss this in the form of a activity. A. Identify the materials which allow current through it. Allow the current through it. For this, material required. Material required. This material required, I will write like a table. So, what are the material required? So, I am taking some materials. What is that materials? So, materials. So, I am taking iron, aluminium, copper, sulfur, iodine, etc., etc., etc. So, what I am doing means I will construct a simple electric circuit procedure. Construct a simple electric circuit, first point. So, simple electric circuit. Simple electric circuit. Simple electric circuit. What do you mean by simple electric circuit means? I will draw, just observe. Let us take a one battery. So this is the positive terminal and this is the negative terminal of a battery. So positive and negative. Positive and negative. I will connect this battery to a bulb. This is the bulb. How we will connect? By using a one connecting wires. By using a connecting wires. By using a connecting wires. So here three things are available. One is battery, another one is bulb, another one is connecting wires. This is the substance or this is the source which produce the electric current. That's why this battery we will call it as power source. Power source. And the bulb, whatever may be the power produced by the battery, will be taken by this bulb. That's why it is called as a power consumer. Power consumer. Power consumer. Here whatever may be the power produced in a battery, that power is going to transfer from battery to bulb through this wire. That's why these wires are called as power transmitters. Power transmitters. Okay, now. So it is a closed one or open one? Completely it is a closed. That's why it is simply called as a closed circuit. Closed circuit. A closed circuit which are made by power source, power transmitter and power consumer. By using only these three equipments, by using only these three substances, then this is called as a simple electric circuit. Suppose in this simple electric circuit, if we connect different equipments, that is ammeter, galvanometer, potentiometer, different type of things, if we connect diodes, then it is called as a complex electric circuit. That we will learn in the higher classes. So come back to, once again I am saying, is electric circuit made up of, once again I am saying, a closed electric circuit made up of power source, power transmitter and power consumer is called as a simple electric circuit. Is it a closed one now? Now, here I am giving some gap. So now, is it a closed one or open circuit? Now it is a open circuit. Now it is a open circuit. Once if you switch on, here I am giving a one key. Don't think that key means your door key, door locker. It is a switch, key means. Okay, children. So I am placing a key here. Once the key is on, otherwise the switch is on. Once the switch is on, what will happen? From the battery, current will transfer like this and reach this point A. From point A to point B, any chance is there to reach? No. So bulb will glow? No. Because it is an open circuit. So to make it into close, in this place of A and B, what I will do means, I will place one by one what are the materials we are taking in the procedure. So first I will place iron between A and B points and I will check the bulb will glow or not. Next I will place aluminium and I will check the bulb will glow or not. Next copper, next sulfur, next iodine. Like this, each and every case I will place one material and I will check whether the bulb is glowing or not. If the bulb will glow, then we will say that these materials are allowing the current. If the bulb does not glow, then we say that these materials are not allowing current. So where the bulb will glow? Bulb glows. Here iron, yes. Aluminium, yes. Copper, yes. What about sulfur? No. Iodine? No. That means in these three cases we are observing the bulb is glowing. That means these three materials are allowing the current to pass through it. What are these three materials up to now we learned? These three materials we learned up to now as a metals. That's why I am giving a conclusion. Metals are good conductors of electricity. What is meant by conductor? The materials which allows the current to pass through it, that materials are called as electric conductors. So metals are good conductors or bad conductors? What we learned up to now? Metals are good conductors of electricity. These are sulfur and iodine is a non-metal. These are bulb is not glowing. That means these are bad conductors of electricity. So by this the final conclusion what? Metals are good conductors of electricity. Non-metals are bad conductors of electricity. Okay children, most of the time in public exam you got the simple electric circuit diagram is a very important question. So this time maybe chances you will ask the total as a activity. That's why I explained in the form of a activity. Next class we will go to discuss the electric conductivity over. Next class we will go to discuss the heat conductivity of metals. Regarding this all, I am giving a PPTs. Children, carefully note down the notes. I am giving each and every point clearly in the PPTs. Try to note down every point and try to learn. Children, I think you are thoroughly in 1 to 30 elements. Still you are not thorough. Try to learn once again. Thank you. This is the notes for today class. So sonority, I gave activity 2 also. Observe, aim, material required, procedure, observation, conclusion I gave. Then afterwards the next physical properties, ductility, how it is in metals and how it is in non-metals. Then malleability also. So how it is in a definition of malleability, examples, exceptions, and electric conductivity I gave in the form of a lab activity like that. Aim, material required, procedure, observation, conclusion. So children, note down the notes without fail. Thank you.